Hey guys, Daniel here, and today we are going to do the binomial theorem. Now this theorem states that x plus y to the power of n is equal to the sum from k equals 0 to n of n choose k times x to the power of k times y to the power of n minus k. Now that seems to be a mouthful, but let's take this apart and see what it really states. So when k equals 0, the expression is just n choose 0 times x to the power of 0 times y to the power of n, and then k equals 1, then it's n choose 1 times x to the power of 1 times y to the power of n minus 1, and this continues on to n to the power of n times x to the power of n times y to the power of 0. So let's first look at an example. Let's try to expand x plus 1 to the power of 4. Now first we have the first term when k equals 0. So 4 choose 0 times x to the power of 0 times, well, y is 1, and 1 to the power of 4 is just 1, so we can leave it as it is. Now for k equals 1, it's 4 choose 1 times x to the power of 1 times, well, 1 to the power of 3 is still 1. So next term, 4 choose 2 times x to the power of 2. Next term, 4 choose 3 times x to the power of 3. And finally, we have 4 choose 4 times x to the power of 4. And this simplifies as, well, 4 choose 4 is 1, so x to the power of 4, plus 4 choose 3 is 4 times x to the power of 3, plus 4 choose 2 is 6 6x to the power of 2, plus 4 choose 1 is 4 again, 4x, and 4 choose 0 is 1. So now we know that x plus 1 to the power of 4 is equal to x to the power of 4 plus 4x to the power of 3 plus 6x squared plus 4x plus 1. Now let's look at a harder problem that we can use the binomial theorem on. Given a polynomial px equals x to the power of 4 plus 3x to the power of 3 plus 7x squared minus 11x minus 1 has roots a, b, c, and d. Find the value of 1 over 1 plus a plus 1 over 1 plus b plus 1 over 1 plus c plus 1 over 1 plus d. Okay, first let's see what we should do here. Well, it'd be nice if we can construct a new polynomial that has roots 1 over 1 plus a, 1 over 1 plus b, 1 over 1 plus c, 1 over 1 plus d, so we can just use Vieta straightforwardly to find their sum. So let's try to do that. First, let's create a polynomial that has roots of 1 plus a, 1 plus b, 1 plus c, and 1 plus d. And we note that the polynomial p of x minus 1 satisfies this, because if we plug in, for example, 1 plus a in here, then 1 plus a minus 1 is equal to a, and p of a is just equal to 0. So this satisfies that the roots is 1 plus a, 1 plus b, 1 plus c, and 1 plus d. So let's find what this is. This is just equal to x minus 1 to the power of 4 plus 3 times x minus 1 to the power of 3 plus 7 times x minus 1 to the power of 2 minus 11 x minus 1 minus 1. And now let's expand this. I'll put it over here. We know that x minus 1 is equal to, I'll just skip the writing the binomial stuff because that's going to take a long time. And I'll just skip straight to the expanded form, which is x to the power of 4 minus 4x to the power of 3 plus 6x squared minus 4x plus 1 for x minus 1 to the power of 4. Now we do the same thing for the other few terms. This turns into x cubed minus 3x squared plus 3x minus 1 And now this turned to x squared minus 2x plus 1. You all should know this. It's just the squaring of x minus 1. It's a very, very common formula. And this minus 11 times x minus 1, this goes without saying. Minus 1. Now let's simplify this thing. First, we say that there's only 1 to the power 4 term, which is x power 4, right here. Now I'll switch to a different color. Here we are. Now we have x power 3 terms. Here's 1, here's 2. So the first term is negative 4 x power 3, and the second one is 3 x power 3. So this combines into negative 1 x power 3, or just minus x power 3. Now the next term is x to the power 2, x squared. So let's find those. Here's 6x squared minus 9x squared. Remember to distribute. So 6 minus 9 is equal to negative 3. Plus 7x squared, which is negative 3 plus 7, which is 4x squared. And that's all. So we are left with 4x squared. Now we have linear terms. Here's a negative 4x plus 9x, that's just 5x, minus 14x, that's just negative 9x, minus 11x, well that's just negative 9 minus 11, that's negative 20x. And finally, we have the constant terms. We have a 1 here, minus 3, that's negative 2, plus 7, that's 5, plus 11, that is 16, and minus 1, that is 15. So we have a plus 15. Now this is our polynomial. X to the power 4 minus x cubed plus 4x squared minus 20x plus 15. But we're not done yet. This polynomial just has the roots 1 plus a, 1 plus b, 1 plus c, and 1 plus d. But we want a polynomial that has the roots 1 over 1 plus a, 1 over 1 plus b, 1 over 1 plus c, and 1 over 1 plus d. So let this be qx. The polynomial that has roots of these things, well, that's just 1 over, or well, q of 1 over x. So q of 1 over x. But if we plug in 1 over x in this polynomial, we know that the result isn't a polynomial because it has like something over x cubed and something over x squared. And polynomials don't have denominators that are variable. So to fix this issue, we'll multiply this entire thing by x power 4. This clears all the denominators and gives that this polynomial is equal to 15x power 4 minus 20x cubed plus 4x squared. Note that when we take q of 1 over x, we're kind of just flipping the, like everything, the coefficients from, for example, like the constant coefficient goes to the power 4 coefficient, and then the linear coefficient goes to the power of 3 coefficient, and so on like that. Right? Which is pretty interesting in my opinion. Sorry there, that was the wrong color. Minus 4x squared minus x cubed, and returning back to our base color, plus, oh shoot, that's not x cubed. That is supposed to be x power 1. Sorry about that. Plus 1. Okay, now we have finally reached a polynomial with roots 1 over 1 plus a, 1 over 1 plus b, 1 over 1 plus c, and 1 over 1 plus d. So now we can just use Vietta's formulas to get that the sum of these roots is 20 over 15, which is, if I can do my math correctly, 4 over 3, and we are done. This is called a binomial. It's pronounced N, choose M, and I'll show you why in a second, but the definition is you have